So we are putting all the pieces together. We've been learning about the physics of flight, and today is the day where we take all the little pieces we're learning about and get a really good picture of how an airplane actually flies. So our objectives for today are to be able to explain how lift is generated, because that's the one piece of flight we haven't really talked about yet, and then to describe the four forces that affect a plane in flight and how they affect it. Sound good? All right, so when a plane flies through the air, there are four forces acting on it. Those four forces are thrust, that's the force that comes from the engines or the propeller, okay? So the thrust force, the force of weight, which is just another way of saying the force of gravity, okay? That one's pulling down. Drag, the force of air resistance, and lift, the force that allows the plane to move up into the air. We have covered generating thrust, right? We talked about how propellers provide thrust. We talked about forces, okay? And we've covered weight. We've talked about the force of gravity, okay? You guys did a brief introductory lab to drag, so you have covered the concept a little bit of air resistance, but today we're going to cover it in the notes. And then the main thing we're going to focus on today is talking about how to generate lift, because it's a complicated process that it took us a long time to figure out. Okay? And then after we have done all of those, then we'll put it all together and see what it looks like. Let's talk a little bit about drag. Okay. The force of air on a moving object is called air drag, or you may hear it called air resistance, okay? And this is the force that's going to act against the forward force of the engine, okay? So the engine is pushing the plane forward. The drag of the air is pushing backward on the plane. So they are moving in opposite directions to each other. Several factors affect how strong drag is on an object, and we're going to talk about those factors. Okay? The first one is the shape of the object. Okay? So if that shape is jagged, right, like a box or a square, or if it's rough, okay, then you're going to produce more drag than if you had a smooth surface. Okay? This makes sense when you think about the fact that air resistance is just a different form of friction. And if you have two smooth surfaces, they don't catch on each other as much, and then you don't have as much friction. The same thing applies to air resistance. We can't really smooth the air, though, so we can only affect the air resistance by smoothing the object that the air hits. The next force we need, or not force, but factor we need to consider is the area of the object. Okay, so you may have discovered this during your lab, that if you have more surface area come in contact with the air, then you will have more drag. Okay, so that's why a larger parachute slows an object more than a smaller parachute, because there's more surface area coming in contact with the air. It's also why a crumpled sheet of paper falls down to the ground faster than a flat sheet of paper. The flat sheet of paper is experiencing more drag because there's more surface area. Okay? So when you consider these past two things, when you consider that the smoothness and then the amount of surface area affect drag, you can begin to understand why we streamline objects. When we streamline objects, we make them smooth, so instead of being boxy, they'll be rounded. And then we also have them come to a point where they would meet the air. So if you've seen really fast objects like airplanes and bullet trains and fast cars, you'll notice that the front of those objects where they're going to come into contact with the air the most comes almost to a point, right? So that they run into less air and the air just slips smoothly over them. And as a result, they experience less drag. The last factor that really affects, or not the last, I think there's two more, factor that affects drag is the density of the air. Okay, so here on the Earth, there's a certain amount of air per unit of area. But as you move further and further away from the Earth's surface, and you get closer to the outer edges of the atmosphere, the air becomes less dense, which means that there's less air per unit of area. So there's fewer particles, which means if there's fewer particles to run into the object, then they will experience less drag. Okay, so up in the upper atmosphere, you experience less drag. And now truly the last factor that affects it would be the square of the object's speed. So this means that the faster you're going, the more drag you experience. And because it's the square of the object's speed, that means if an airplane is going 40 meters per second, that's only double 20 meters per second. But because we're squaring that, it experiences 4 times the amount of drag, not just double the drag. Okay, so it goes up much faster than you think it might. So the faster you're going, the more drag you experience. Okay, now we understand drag. So we've got an understanding of the force from the engines, the force from gravity, and the force from air resistance. So now we need to understand lift. Okay? Lift is the upward force that's on the wings of an airplane, and this is the force that is in opposition to gravity. So just like the engines were pushing forward and air resistance was pushing backwards, gravity is pushing down and lift is pushing up. Okay? To understand how wings generate lift, we need to go back to our understanding of Newton's third law of motion. So if you remember Newton's third law of motion, that was for every action, there is an equal and opposite reaction. That means any force that is applied to an object, that object applies an equal force in the opposite direction. So it applies it back on the object applying the force. Okay. So the example that we often use is when you push on the wall pushes back on you. Okay? Equal forces in opposite directions. Okay? So how does this apply to generating lift? Well, when a plane is flying through the air, the wings of that plane are pushing on the air because they run into the air and they push on it. And when they push on it, they cause it to change direction. Okay, so when the wings push the air down and out of their way, then we know because of action and reaction that the air needs to push up on the wings. And when the air pushes up on the wings, it generates lift. Now we know that this doesn't mean that immediately the plane just jumps off the runway, right? Because we have to produce enough lift to overcome the force of gravity, okay? Which is why planes have to travel so fast, because they have to overcome a lot of weight, right? And it's also a reason why we try to make airplanes out of really light materials so that there's less weight from gravity to overcome. Okay? And on its own, just this action-reaction of wing pushes on air, air pushes on wing, isn't quite enough to produce the lift necessary for flight, but there are some factors involved that will increase the strength of the lift, and we're going to talk about those. So, what are the other forces that can help generate lift? Well, there are a few ways to increase the lift that is generated by the wind, okay, or the air. Okay, the first one is the shape of the wing. So you'll notice that aircraft don't just have a flat blade sticking off of them most of the time, okay? Most of the time, what you'll notice is that the shape of the wing is flat on the bottom with a gentle curve on the top edge. This is called an airfoil, okay? Spelled just the way you think it would be, airfoil, okay? So this shape helps produce lift. The wings have wide flat bottoms and gently curving tops, and how they do that is the shape redirects more air down, causing the air to push up. Okay? If you just had a flat wing, not all of the air that you ran into would get directed downward. But if we're looking at this shape again, right? As air goes over, it's directed downward, and as air goes under, it's directed downward. So both of those being directed down a little bit causes that opposite force to be directed up and generates lift. There are also two effects due to the shape of the wing that increase lift. We're going to talk about them here in just a sec. The first of those two effects is called the Bernoulli effect. The Bernoulli effect states that when air moves faster, the pressure it exerts is less. Because air must move a longer distance over the top of a wing, it has to move faster than the air that's moving on the bottom. So briefly, just go back to this picture of the wing, right? Air that moves here is traveling a longer distance, which means if it's going to do it in the same amount of time, it has to travel faster. That means the air on top of the plane wing is always traveling faster than the air that's going underneath it. And as we just learned from the Bernoulli effect, air that's moving faster has a lower pressure. Okay? Less pressure, less force, which means there's an imbalance in pressure. There's less pressure, less force above the wing than there is underneath. And as a result, that causes an upward force on the wing. So we've just increased our lift by having a difference in the pressure. You may have experienced the Bernoulli effect if you've ever walked between two buildings. So there's two buildings and then there was wind blowing through them. The wind that's blowing through those buildings is much faster, and sometimes it can even suck the breath out of your lungs. If you've ever experienced that, you were experiencing the Bernoulli effect. And the second effect is the Coanda effect. Okay? This effect states that molecules that are in a fluid, and in science when we talk about a fluid, we mean either a liquid or a gas, because they both behave in similar ways. Okay? So when molecules in a fluid flow over a curved surface, they are going to be weakly attracted to that curved surface. On an airplane wing, the air is attracted to the wing's upper surface because that's the portion of the wing that's curved. Okay? So when you have your wing, lovely little curved wing here, okay, the air that flows over the top of it is got a weak sort of attractive force between it, okay, which means that not only is the wing pulling on the air, but then that means that the air is also pulling back on the wing, because remember, every force has an equal and opposite force. So when that air is attracted to the wing, then the wing is also attracted to the air, and as a result, the equal and opposite force of that attraction pulls the wing up. So we have both the Bernoulli effect and the Coanda effect producing increased lift on this wing. Additionally, being attracted to the wing causes a greater deflection downward as it leaves the end of the wing, which means that that action-reaction force we talked about changing the direction of the air is also stronger. So we are just increasing lift all over the place here. The last thing that increases the upward lift of a wing is the angle of the wing. Okay? So when an airplane is flying, normally, all of the things we've talked about are generating lift in the upward direction, right? But you have probably seen some aircraft that are able of doing loops and turning their plane upside down and continuing to fly, correct? Well, if we turn the shape of the wing upside down so that now the flat is on the bottom and the curve is on, or the flat is on the top and the curve is on the bottom when the plane is flying, then any lift we're generating from the shape of the wing is all pointing in the downward direction, which would mean that it would be impossible for a plane to fly upside down, which means that these cannot be the only sources of lift, right? Instead, the angle of the wing also affects the lift. To understand this concept, we need to understand angle of attack. Planes almost always fly with the front edge of their wing slightly higher than the trailing edge. So I have been drawing the wing like this, but in reality, the wing would be more like that, where the front edge is slightly higher than the back edge. This is called angle of attack. It causes air to hit the bottom edge of the wing. So if you look at that picture again, right? When it's like this, more of the air that's striking it is striking the bottom of the wing. And when it strikes it, it gets deflected down and it pushes up on the wing. This increases the air pressure on the bottom of the wing and generates more lift. And this process works no matter what direction the plane is flying in. Okay? So this one here is the major generator of lift for us. Okay? However, you'll notice that planes don't just crank that angle up as high as they want, because the steeper you make the angle, the more drag you receive, and also it can affect how the air flows over the curve of the wing, and if the air is disrupted so it can't smoothly flow over the wing, we lose a lot of lift. So you have to find the right angle of attack so that you are generating the maximum amount of lift you can while still minimizing the amount of drag that your airplane is receiving. Now we understand the four forces that are affecting our plane, right? So now we can put it all together into a picture of how planes fly. We have thrust pushing forward, drag pushing backward, lift pushing up, and gravity pushing down. Okay? When the plane is in the air and it's not accelerating, the four forces must all be balanced, which means the plane can move up and down and it can move forward, but its speed doesn't change. Okay? So when the plane is cruising along, going the same speed all the time, then it does not have, the forces on it have to be balanced. So that means lift is balancing the downward force of gravity, and the thrust of the engines is balancing the backward force of air resistance. If the plane wants to go faster, it'll have to apply more thrust. If it wants to go slower, it'll have to apply less, and so on and so forth. The four forces are going to change during the course of a flight, though. Okay? So they're gonna be different. When the plane is sitting on the runway, as we talked about at the beginning of class, there is no lift, there is no thrust, and there is no drag on this airplane. The only two forces on the airplane are the weight of the plane pushing down on the ground because of gravity, and that sentence is weird. I must have written it wrong. The weight of the plane on the ground because of gravity, and then the force of the ground up on the plane. Okay. However, when we add thrust from the propeller or engines, we set the plane in motion, and it starts to accelerate and speed up as it goes down the runway. As it moves, air begins to flow over the plane's wings and starts to create lift. The faster the plane goes, the greater the lift becomes until, and as well as the force of drag is increasing, which means you have to keep increasing the thrust from the engine. Eventually, that lift force is greater than the force of gravity, and the plane takes off into the sky. Then, as we discussed, the plane can cruise around in the air by manipulating those four forces. And when the plane begins to slow as it's coming in for a landing, lift is reduced. The force of lift is eventually reduced until we get to what we call the stall speed. The stall speed is the speed at which a plane no longer generates enough lift to overcome the force of gravity, and it will fall out of the air. Now, if you hit the stall speed in the middle of the air, that's a problem. But pilots are trained well, so they know how to decrease the speed of the plane just so that they hit the stall speed moments before the plane drops onto the runway. And there you go. There's your physics of flight. Your homework is questions 1 through 4 on page 725 of your textbook. Go ahead and get started.